Welcome. Thank you for joining us today for our webcast, How to Monitor and Observe IoT and MQTT Applications with HiveMQ. I'm happy to introduce you all to our speaker for today, David Gushakowski. He is a sales engineer at HiveMQ and serves customers by identifying the needs and providing them with technical support. He has provided project and sales consulting services for many years in the area of data integration, application integration, data management, and messaging. Drawing upon his experience, he helps HiveMQ customers to achieve best possible outcomes with their IoT solutions. His primary focus is on maintaining a high level of customer satisfaction at HiveMQ. Joined by David is Ian Scarrett, Head of Marketing at HiveMQ, who will be available for Q&A. David and Ian, thank you for joining us today. And before we get started, I would like you all to know that we are recording this session and all participants will be on mute. We'll be running a live 15-minute Q&A at the end of the webcast. If you have any questions during the presentation, feel free to type them into the QA box in your control panel. If we cannot answer them in all, we will answer them in our community forum or email you later. Now, without further ado, I will turn the time over to David. Welcome, everyone.
Hi, everyone. So yeah, today we're going to talk about IoT observability. And this is basically the agenda. First, I want to introduce a little bit the differences between observability of, let's say, classic IT systems, integrated systems, and IoT systems, and also the challenges that come with it. And yeah, I want to give a little bit of context to it by providing an example production issue that we actually once had that we just sanitized a little bit so that nobody knows who it was. And yeah, we want to show a little bit the capabilities of the HiveMQ broker to reduce the time to resolution. And yeah, round it off with a live demo so that you can also see it a little bit in action. So yeah, I mean, Jayashri said it a little bit. I actually also grew up in the, let's say, classical IT world, in the ESB world, in the integration world, where you have a lot of distributed applications at a large scale. You have to handle with a lot of messages, and but you have a lot of basically all your actors, all the systems that you that are talking to each other. They all know each other, and you can basically introspect them. You can observe them, and you're kind of in a situation where hardware is not that big of a problem for you. So whenever an error occurs, you kind of know that you're kind of in trouble if there's a technical issue. And that's, in my opinion, that's one of the fundamental differences also to the IoT world, because there you kind of have to live with errors simply because, some of your actors are running on batteries, they're in a bad network, so they have issues all over the place, and you kind of have to deal with the case that actually issues are happening or errors are happening, and you have to react to those that are really critical to you and your business. And I mean, with the involvement also of IT applications over the years, I think a lot of the observability of IT system has really, evolved. I mean, when I started in 2007, I mean, we had observability applications, basically custom ones for every new project that I worked for. And with Kubernetes and the REST APIs and all those things, this has evolved really, and a lot of observability applications also have evolved. And we're also taking advantage of these. And this is what I'm going to show you a little bit also later on. Yeah, but what are actually those difficulties that I'm talking about? I mean, I mentioned a little bit already. You have to identify errors and kind of an error noise. And I mean, a lot of IoT applications are based on messaging, so based on MQTT. And there, when a message is lost, I mean, it depends a little bit on the use case, obviously. It can either mean like a tremendous problem, like when you really have regulations attached to it and things like that. But also, I mean, it's always kind of a problem to you if a message arrives late or if it's lost, you have to deal with that situation. And in IoT, it's very common that messages can be lost simply, software errors, programming errors, but hardware errors. I mean, if you think about connected car, if a car goes in a tunnel, you will have probably a network error and a disconnecting client, and it doesn't necessarily mean a problem for you. And same can be for the hardware itself, if it runs out of battery and things like that. And so you have constant noise of disconnecting clients and potentially not being able to access them. And you have to deal with that and have to identify quickly when it becomes a problem for you as a company. And to top that up, IoT applications are even they generate even more data than traditional IT applications. I mean, data, as you all know, becomes more and more and more, and with IoT, it will grow tremendously. You have a lot more clients connected to it, and they generate a lot more data. And those traditional monitoring tools, network monitoring tools, they just simply don't work the way anymore as you're expecting it. Like a Wireshark, if you turn it on, it will just simply kind of explode because of the amount of data that it has to deal with. So actually, your communication infrastructure needs to deliver that kind of functionality to you to do this live data analysis without impacting the performance too much. And therefore, you need to have kind of filters to drill into the system and see what could be the affected devices or connected clients that have problems, what could be the root cause of it. And I mean, also with the traditional applications, IoT applications are made is a system of systems. So many components and custom developments and software from different vendors that need to interoperate and need to work together. And in order, to get a clue of what is happening, you want to rule out that they are at least working, from a technical perspective, that they're healthy, and therefore all your applications need to be able to generate metrics or report basically their status of health, so that you can make sure that this at least is not a problem. And yeah, I mean, these are kind of the three major differences, or where it really comes into place that observability is kind of an important topic that you really need to think about when you choose an MQTT broker. And to round that off a little bit and give it a little bit more context, this was actually a real production issue that happened a while ago. Basically, there was a car sharing service that we support, and it had in Frankfurt all of a sudden 8,000 cars that just didn't connect anymore, didn't work anymore. And the support center was basically overwhelmed with support calls, and in a reactive state, you're not ahead of the situation. You really need to react and need to have a way to cope with such a situation quickly. And for them, initially, the whole system appeared just like a black box, and they just saw that the system somehow is not working for everyone, and it is kind of slow. And HiveMQ, as the broker, actually had significant part in finding the root cause of the situation and getting to a quick solution. And basically, they used our tooling, our observability capabilities, to identify that the issue was actually based on the cellular network provider that just didn't work in that particular area at that point in time. And because of that, they could directly get also in contact with the team, build a task force, and inform affected customers and get to a quick resolution. Yeah, and how does HiveMQ basically does that? I mean, what kind of capabilities does it provide to get to a resolution quickly? It has a set of capabilities to do that. So the first thing is we have a built-in dashboard in our broker that basically allows you to observe from a technical perspective, but also from an MQTT perspective, what is going on in the broker cluster. So you basically can observe the whole cluster with the dashboard when you have multiple brokers that work together. You can look into many different metrics. I will show that later in the demo a little bit. But also we basically offer metrics, or we basically export metrics through an JMX endpoint, but also through extensions, so that we can basically integrate into all those modern performance monitoring tools, like, I don't know, like Prometheus and InfluxDB as time series database with Grafana on top, as you see here, or Datadog or Splunk, and yeah. So with this combination, you can, from a technical perspective, and also from an functional technical perspective, you can observe the system and make sure that at least the system is healthy. I mean, this is kind of it's as old as IT, logging. As it's a highly distributed system, we also need to support kind of a central logging approach, and we rely on Logback. Where you can create your own appenders and basically do consolidated logging into like syslog or from Elastic. I mean, these, these central logging systems. We do offer multiple log files, and especially also for extensions. So if you, for example, use our security extension, it comes with its own log file, so that you have separated logs and can identify issues very effectively and look into the log files that you think are somehow the root cause of the problem. And now it gets a little bit more into the functional aspect. With client and topic tracing, you can then really start to do a tracing on the broker cluster. And basically, similar to Wireshark, you can then monitor what is going on in the system, what are the clients, how are they connecting, when does a publish happen, and unsubscribe, subscribe, disconnect, and all these kind of things. And you do that basically by specifying time frame, the range of devices. You can also specify wildcards, basically via regex. Similarly also for topics, and then you set basically this MQTT messages that you want to trace. And this enables like a very fine-grained diagnostic of what is going on. I will do that later a little bit in the demo and show you what the outcome is. I mean, the cool thing is also in the broker cluster, it basically you can retrieve this information for all the cluster members in one step, and then start analyzing this. Yeah, and I mean, this goes a little bit hand in hand. If you have clients that are disconnecting, that are somehow behaving weird, or that you somehow expect they don't do what they're supposed to do, with the device health, with the clients overview, you can basically drill down into clients and into their details and see the connection details, what MQTT versions they're using, authentication information, but also client event history, like when did they connect, when did they disconnect? Was it maybe because of an overload protection, like too many clients connected at the same time and it was just kind of pushed back? So this kind of reasons you can observe here. And it goes a little bit in the same direction when you have dropped messages. I mean, when a message, when you have a lot of load on the system and you maybe have a, a consumer that it cannot cope with the load that it is supposed to receive, and simply receives too many messages and cannot work them off quick enough, messages can be dropped. And it's kind of a, a resiliency and security measurement that you want to take to have a healthy broker. And in order to find out why this has happened, we have also a drop message analytics overview, where you can see when did this happen for the first time, the last time, how many, and for which reason this also happened. And a little bit, I mean, this is kind of functionally covering the same thing, but from a different angle. We have so-called MQTT add-ons. And they basically allow you to functionally react on issues, things that happen. And similarly to this, to the drop message overview, we can also functionally react to it, because we basically, you can activate on the broker that these messages get duplicated to the so-called dropped topic. And then you can consume basically messages from the drop topic. And actually, it doesn't just get duplicated into the topic, also the same information like when did it start, like timestamps and reasoning gets also added to it, so that you could, for example, use it simply for like your data lake that you can analyze it later, or you can directly feed it into machine learning and try to get a clue on why these things are happening. Maybe, you know, at this particular time of the day, always message gets dropped. And with machine learning, you kind of could develop solutions to it so that you can get ahead of the situation next time more easily, and then incorporate it into your error handling framework. And I mean, this is not only available for dropped messages, but also for expired messages. So if a client takes too long to consume a message and the message itself expires, or if a client is just offline for too long and couldn't consume it on time, or for retained messages if they just expire and have been too long on the broker and then will just get thrown away. And with the expired topic, you can still consume them and make use of them. And actually with 4.6, there's a new functionality, a new functional topic added, the so-called dead topic, for those messages that are sent to a topic where you actually don't have a subscriber at the moment. So normally in the MQTT world, it would be kind of lost. With the dead topic, you can still consume it and make use of it, and you know, do the things that you need to do with it. So let's do a little bit of demo on top of it to show these things a little bit more in action, especially the observability views. And before I start, I use our testing tool, HiveMQ Swarm, to push some messages into the system. You don't see this at the moment, but I just started Swarm so that we can get some messages into the system. So it starts connecting and then starts publishing. And as you see here already, the inbound publish rate starts. So you can see for every of these categories over the last hour, you can see what is going on in a graphical way, both for the inbound publish rate, so for those messages coming in, and for those that are consumed. You can see the number of subscriptions in the system, the number of retained messages, but also queued messages. So I created kind of a case where a client just connects and then disconnects, so that we can also get some queued messages, and I can show it a little bit. And here you can see accordingly also a notification directly that this has happened, because this typically means that something is not going in the right direction. Down here, you see the license on the left, and on the right, you can also see the current information about the system. So before I move over, let me quickly also show, just based on example, dashboard that you can actually download also publicly from one of our blogs or from the blogs. A Grafana dashboard that is built on top of Prometheus, and actually from the broker, we use the Prometheus extension to expose metrics, and actually more than 1,000. You can actually, you know, define it in a fine-grained manner based also on the resources that you have, like if you have multiple disks and multiple, depending on the CPUs and network interfaces, you can define metrics for each of those hardware resources that also help us to help you in case you are in a production scenario and in a production issue. Yeah, with the Grafana dashboard, you can basically do, you know, the monitoring, and you probably are used to it based on various time frames. I think I started my broker today somewhere at lunchtime or a little bit later, and can really drill down into the technical aspects of the broker cluster, and combine it obviously also with the health of the other connected systems. Cool. So we have a little bit the system monitoring part covered. Let's take a look into the job messages maybe as the next step, and go directly into the analytics job messages menu, and see here basically the clients that we specifically configured so that they just connect and disconnect, and all messages for them are queuing up. And as said, you can see here basically when it happened, the amount of messages, and could also see it, of course, for shared subscriptions. When we are looking at clients and why this is happening, just refresh the snapshot. So to cope with the load, I mean, you need to do kind of snapshots to basically take kind of a peek into the system, and then start your analysis and see what's going on. And here you can basically just, in a fine-grained manner, really go and drill down into the client that you want to see by username or by the IP address. If you have kind of a cellular problem, it's probably related to also a range of IP addresses. You can simply filter, and then you can go into each of the clients and see those, specific information around IP address. How did it connect? Was it clean start? Was the authentication information, and all those technical things. And let me see. For backend. Here we can also see either the regular subscriptions, or if it's part of a shared subscription, we can also see then the subscription and what the quality of service is. And when you actually activate it, I haven't activated, you can also see the event history. So when did it connect? When it did disconnect, and was it disconnected because of a overload protection mechanism, like too many connections at the same time, and to prevent system overload. Right. For the offline, I mean, you have obviously not all this information, but like the current connection is not there, so no connection information, but a similar view that helps you to identify what the root cause could be. For shared subscriptions, you have a similar view as well here, where you can basically also get an overview which clients have shared the same shared subscriptions, because typically you have a set of clients that get these messages in a round-robin fashion, and you want to know if actually you have enough clients connected to it. With retained messages, you can actually look into the last retained message of a topic. You could just click on it, see when it happened, when it expires, quality of service, and you could also show the payload. And with our HiveMQ Swarm, we basically just generate random messages for our little scenario here. And that's basically what you see here, this random message. And a very cool feature is actually the trace recording. So if you go, a next step, you kind of know that something is going wrong, and you want to monitor into the system and want to see what is happening. And with the trace recording, you can basically do something similar that you are probably used to do with Wireshark. So you basically, from an MQTT perspective, you monitor the interactions between the broker and the clients. So I would do here a test 2. You specify the time frame, as I said before. You could, for example, say for specific topics, because I'm still receiving messages, I can just do that and show you what kind of is recorded at the time. When I start now the recording, it basically starts it, and you can download at any time the outcome of such a recording. Okay. So let me move it into the browser. And you can see here that basically publishes have happened, and you can examine them also when you add client information and the connect information, you can then basically follow the full life cycle of a client from connect to disconnect, and all the things that he's doing, you can follow that. And actually, we also allow to could also watch the payloads, but here this is one of the things that you would actually need to activate, because this obviously creates a tremendous amount also on the disk. It consumes a lot of disk space to save this additional information for a longer period of time, because simply, millions of clients sending millions of messages, this obviously creates a lot of traffic, but also disk size. So, but this feature really allows you then to drill down into a set of clients and find out what could be wrong from a broker perspective, and this helps you to identify the issue that has happened. Yeah, and this is mostly it. The admin function is more around making backups so that you could also transfer the information to another broker, but simply for observability, these are the features that we provide, obviously among others, like the logging and these kind of things. But from a dashboard, this already gives you a lot of capabilities that help you to identify issues. Cool. So this was my little webinar, and here are some additional resources. HiveMQ. Please download it, use it. You can even use it without a license, with up to 25 connections, and try out this functionality yourself. Also, the control center, here have an overview from our documentation. I mean, as the whole solution, it's very well documented, and there you can get also some additional information about the things that I just explained a little bit. And with HiveMQ Cloud, you can obviously also consume our services directly from a managed service or from our SaaS application. So, thank you. Jayshree, I think you're taking over, right?
So so Jayshree, do you want to introduce the poll?
Yes, I have introduced the poll already. You can take over here.
Okay, so we have a poll. So please take the time to complete the poll to give us a better idea of kind of you're interested in this topic. We're also open to questions. David's available for questions. So if you have questions about the presentation or anything about HiveMQ, we'd be happy to ask to try and answer them as best to our ability. So we do have a question that it came in from Rama. They're evaluating HiveMQ Cloud. And they've got two questions, it looks like. What kind of database service you provide with HiveMQ Cloud? Can any other person see the message being transmitted? I published my device ID, subscribed to my device ID. I got the data. Sorry. Two questions. What kind of database service are provided with HiveMQ Cloud? David, do you want to take care of that, or?
I'm actually not sure. I think this is a question for our cloud team that we would actually need to find out. I assume it's actually for the security part. I mean, we basically generally we support all of them. Which one we are using specifically, I'm not sure. I would guess it's Postgres likely. But
yeah. So, but for database, I'm pretty sure the database service would be kind of storing MQTT data in a database. Would be my interpretation of the question. And right now, HiveMQ Cloud doesn't provide any integrations for that. We certainly we're working towards providing integrations for cloud, but right now you'd require to write an MQTT client that would subscribe to the kind of the MQTT messages that you want to store in a database, and then use that client to store it into the database external to HiveMQ Cloud.
Or alternatively, use an extension to do it directly from the broker. I mean, either
but this is with HiveMQ Cloud though, right?
You're right.
Right. So the second question is, can another person can see the message being transmitted? So no, you've got a private a private, it's a shared broker, but the messages are private to your tenant for that. So hopefully that answers your question. You're supposed to talk about OT. What is the OT part of in your presentation? So I'm not quite sure kind of. So HiveMQ in general is used in factory automation, where you kind of, so you can connect PLCs that are generating MQTT messages to the broker. We've actually done previous webinars on this, so we can certainly kind of put links in the chat to these webinars. But in general, the observability features are certainly applicable to operational technology side too. Extension from HiveMQ to Kafka, is this in-house or third party? David, do you want to handle that?
Yeah, that's in-house. That's one of our enterprise extensions that you could basically also purchase as part of the broker solution, and configure it to your needs. It's bi-directional, and it's very much performance optimized and security optimized, so that information is encrypted over the wire, and you can push it, MQTT data as quick as possible to a Kafka broker cluster. So yeah, it's provided by us and supported, of course.
There was another question in previous, I'll just repeat that I answered online, was for testing tools, performance testing tools. There's a question about that. And David made reference to HiveMQ Swarm, which is our performance testing tool that we released back in April. So if you're interested in performance testing, we do have a tool that basically allows you to simulate MQTT clients, and that's what David was using to show his demo here. He was kind of simulating the clients using Swarm. So, all right, I think we're at last kind of chance to ask a question. If people have anything, that your last chance. Certainly, if you want to follow up with us, we'll be happy to follow up with any other questions. Our community forum is a great place to go for questions too. So, all right. But with that, I think we're out of. Oh, sorry. Here's a clarification. So we'll just sneak this one in. To clarify, I'm involved in OpenCUA. I'm leading an open source project with C++ implementation of OpenCUA. This context, I'm using HiveMQ for my prototype. Are you interested? Sure. Yeah. So certainly feel free to reach out to probably reach out to myself directly. So my email address is ian.skerrett, SKERRETT @hivemq.com. Now that I think of it, we'll have it's Michael's email address in the Q&A, so I'll reach out to him directly too. And actually, there's another. Can I use HiveMQ on premise on the edge without license? I collect many sensors in the field level, 1,200 sensors or an actuator. Let me take this. So we have an open source version of HiveMQ that's available, and you can use it wherever you want. It would certainly handle 1,200 sensors and actuator. The open source version does not include the control center that David showed today. So just be aware of that. So it's not included. That's only available in our commercial versions, the professional and enterprise versions. But there is a broker available. We also actually have HiveMQ Cloud, which actually for the first 100 devices is free. So if you wanted to kind of start with HiveMQ Cloud, kind of just before you, if you're doing things like proof of concepts, that's also available for free. All right, I think we're at the end. Jayashree, I'll let you wrap it up.
Cool. Okay, thanks everyone. So we hope you all enjoyed the session. So if you would like to watch it again, we will upload this recorded session onto our HiveMQ YouTube channel. and all unanswered questions will be answered on our HiveMQ community forum, or we will email you with the form of follow-up email. Okay, thanks again, everyone, for joining us today, and we'll see you next time. See you.
Thank you. Bye-bye.
Bye-bye.